Hello Bacha Party, a very good morning to all of you, and once again welcome to your channel TKG Physics Classes. So students, all of you know we already completed, there is a linear displacement, angular displacement, linear velocity, angular velocity, and the relation between linear displacement, angular displacement, the relation between linear velocity and angular velocity. That is the basic part of circular motion. Now today in this lecture we will discuss a force, is very important force which is required to move a body in a circular path, that is named as centripetal force. And after that we will discuss the circular motion of a car on a level road. So for knowing the second part, that is the circular motion of a car on a level road, at first we have to know the meaning of centripetal force. When centripetal force required, what is the expression of centripetal force? What is the actual meaning of centripetal force? It is a real force. So we will discuss first of all, that is the centripetal force. At first you write down the definition. You see, this is the definition of centripetal force. That is a force which is required to make a body along a circular path with a uniform speed is called the centripetal force. So for knowing the centripetal force, at first you have to know the basic meaning. Suppose a body is moving along a circular path. A body of mass m is moving along a circular path. This one. This is the circular path. A body is moving along a circular path. So tell me, what is the direction of velocity? The velocity direction, that is tangential. So at this point, this is the direction of velocity. At this point, this is the direction of velocity. Here, the direction of velocity, that is tangential. Here, the direction of velocity, that is tangential. So here, suppose this circular path has radius r. Velocity at every point you see, that is tangential to the surface. Now question is, this velocity is changes or constant? Answer is, this velocity changes. You see, at every point the direction of velocity changes. The magnitude value may changes, may not changes, but the direction at every point is changes. Now question is, when the direction of velocity changes, there arises an acceleration, and this acceleration is called the centripetal acceleration. So what is the meaning of centripetal acceleration and when it arises? When a body is moving along a circular path, the velocity at every point, the tangent gives the direction of velocity. So at every point the direction of velocity changes. As a result, it arises an acceleration, and this acceleration is known as the centripetal acceleration. Now question is, what is the direction of this centripetal acceleration? This centripetal acceleration is always directed towards the center along the radius. You see, this is the direction of centripetal acceleration, AC, towards the center along the radius. At this point, this is the direction of centripetal acceleration, towards the center along the radius. At this point, towards the center along the radius. At this point, towards the center along the radius. So first of all, velocity changes. Velocity changes, that means direction changes. Direction of velocity changes. As a result, there arises an acceleration, and this acceleration is named as AC, or you can say AR. Why AR? AR, that means it's directed along the radius, that's why sometimes it is named as AR. And what is the expression of this value? That is V square upon R. Now you know the meaning of V and omega. V, that is equal to omega into R. This is the relation between linear and angular velocity. Now you just use here, that is V square, that means omega square R square upon R. So 1 R cancel out. So this answer will be omega square R. So omega square R, or you can say V square by R, this is the expression of AC, and AC is named as the centripetal acceleration. And what is the direction of the centripetal acceleration? It's directed always towards the center along the radius of this circle. Now tell me one thing, which physical quantity is the origin of this centripetal acceleration? Which physical quantity produces this centripetal acceleration? Obviously all of you know, according to Newton's second law of motion, the expression of force, that is F equal to m into a. When a force applied on a body, the body gets acceleration. So here it is represented like this way. Fc, that is the centripetal force, is equal to mass into AC, and AC is the centripetal acceleration. This centripetal force produces centripetal acceleration, which is represented as AC, and the value of AC, that is v square by r, or you can say omega square r. So write it, that is Fc is equal to m AC, that is v square by r, or you can write this value omega square r. If we write, this one will be m omega square r. So this is the expression, this is the mathematical form of Fc. Fc is represent the centripetal force. And you see, remember one thing, when any circular motion happens, there is an acceleration, and this acceleration is known as centripetal acceleration. And this centripetal acceleration is produced by the centripetal force. So for any circular motion of a body, there required a centripetal force, and which is directed. What is the direction of this centripetal force? You see, the direction of the centripetal force, that means the direction of this centripetal acceleration, or you can say the reverse one also. The direction of centripetal force is the direction of centripetal acceleration. That means the centripetal force is also directed along the direction of AC, and the direction that is towards the center. So this one is the direction of FC. AC, direction of FC and AC are same. Now you see, AC and V is perpendicular, always perpendicular. So this is the expression. Now question, one thing, is this a real force? This is not a new kind of force. Always mind this part, centripetal force is not a new kind of force. The material forces like you can say tension, gravitational force, or frictional force, these types of force act as a centripetal force. Centripetal is a name given to any force which is directed inward towards the center of a circular path. Suppose a stone is rotating along a circle. A stone is rotating like this way. So you see, when a stone is rotating like this way, this is a fixed point, a stone is rotating like this way. This string has a tension inward, in the inward direction. This tension is directed inward towards the center. So here this tension force provides the centripetal force. Centripetal is not a new kind of force. The material forces like tension, frictional force, gravitational force, all these types of forces act as a centripetal force. When a car makes a turning along a horizontal path, level road, the frictional force between the road and the tires of the car provides the centripetal force. Here frictional force provides centripetal force. Centripetal force is not a kind of new force. Okay, so centripetal is a name which is given to any force, which force is directed inward, radially inward towards the center of a circular body. So this is all about the basic concept of centripetal force. So the basic concept, it is directed towards the center. Expression, that is mv square by r, or you can say m omega square r. Okay, now we will discuss the second part. Okay, before going to that part, at first you see this example, then it will be more easier to all of you. You see, write this one. So here a ball of mass 0.1 kg is suspended by a string, you see, and the string length, that is 30 centimeter. This length 30 centimeter. This is the vertical line. Okay, mass here, mass m, that is equal to 0.1 kg. Now it makes a horizontal circle. It makes a horizontal circle like this way of radius 15 centimeter. This length is given 15 centimeter. Now you have to calculate the angular speed. That is, you have to calculate, according to our problem, you have to find out the value of omega here. Okay, angular speed. See, this length 30 centimeter. Suppose this angle is theta. This is 15 centimeter. So if I write the value of sine theta here, what will be the result? Sine, that is perpendicular by hypotenuse. So here this is the base. This is the base. So perpendicular, that is 15, and hypotenuse, that is 30. So this one will be half. So sine theta, that is equal to, you can say sine half, that is sine 30. So theta is equal to 30 degree. So this value is 30. Okay. Now you see, you just explain this part in various forces, the direction of various forces. Here a body of mass m, so weight mg is directed vertically downward. Now in this direction along this string there is a tension T. So if this is the direction of tension, this angle is theta. If this angle is theta, so this angle will be also theta. Now see, this component is named as T cos theta, or you can say theta is 30, so T cos 30, and this vertical component is named as T sin 30. Clear? Now see, this part is important, student. Here mg is balanced with T cos theta. Mg downward, T cos theta upward. So write T cos 30, which is balanced with mg. And you see another component of tension, T sin 30. Here T sin 30 gives the direction which is towards the center of this circle. And we just explain the force which gives direction. Any types of force which gives the direction towards the center of the circle is provides centripetal force. So here T sin 30, this component will provide the centripetal force, because T sin 30 is directed towards the center of this circle. So write it. So here T sin 30, that provides centripetal force, and you know the expression of centripetal force. You can write mv square by r, or here you can write m omega square r. We need to find out omega, so here you write m omega square r. Now you divide this part with this one. So suppose this is equation 1, this is equation 2. Now divide 2 by 1, divide it. So on dividing 2 by 1, you can write, you see, T sin 30 upon T cos 30, that is equal to mg, sorry, not mg, this value is m omega square r, and this one is mg. M cancel out, T cancel out, that is tan 30 is equal to m omega square r upon g. Here you have to find out omega square, that is g tan 30 divided by r. So omega is equal to g tan 30 upon r. So you can easily find out this value. You know the value of g, that is 9.8. You use that value of tan 30, and here the value of r given, you see this one, the value of r, which value is this one, 15 centimeter. So you just put the value and you can easily find out the value of omega, and the unit will be rad per second. Okay, so the basic concept, that is any kind of force which is directed towards the center of a circle is provide the centripetal force. It is not a new kind of force. Okay, now we will discuss the circular motion of a car on a level road. Okay, so our next point, that is the circular motion of a car on a level road. So our second topic, that is circular motion of a car on a level road, and in this topic actually we will find out what is the condition for which the car stay on a road. What is the maximum speed that can a car taking a turn safely? So you consider a car of weight mg, this one, this is the car, okay, a car of weight mg is going around a circular path. This is the circular path, okay. So what is the direction of the weight of the car? Obviously vertically downward. This is the direction of weight of the car. Now tell me, what actually happens when the car taking a turn along this circular car path? The tires of the car leaves away. The tires of the car leaves the road and going away from the center of the curve. You just imagine, when a car taking a turn and along a circular path, what happens? The tires of the car leaves the road and taking away from the circular path. That is the tendency of this tire. The tendency of this tire is going away. This is the direction, this is the tendency. But here frictional force arises, and which is directed that the opposite direction of this tendency. That is, frictional force arises which is directed inward towards the center of this circular path. Suppose the radius of this circular path, this is the radius of this circular path r. Here suppose F1 is the friction for inner tire and F2 is the friction for outer tire. Okay, write it. So here weight of the car, weight of car W, that is mg, which is directed vertically downward. Now F1 and F2 are the frictional forces for inner and outer tires. Okay, now see here, R1 is the reaction force. Suppose R1 is the reaction force of the ground in the inner tire, which is directed vertically upward, and R2 is the reaction force of the ground for this outer tire. Write it. So R1 and R2 are the reaction forces, normal reaction forces for inner and outer tires. Okay, so what is the resultant normal reaction force? The resultant normal reaction force that is along this side, that is R1 plus of R2. Two reaction forces R1 R2 which is directed vertically upward, same direction, so resultant R1 R2, and this resultant reaction forces is balanced with, you see, the vertically downward direction, balanced with the weight of the car. So you see here, right here, reaction forces balances the weight of the car, that is R1 plus of R2, that is equal to m into g. Now you know the formula of frictional force. You can write F1, that is equal to mu into R1. Similarly for F2 you can write mu into R2. What is mu? Right, mu is the coefficient of friction between the road and the tires of the car. Now what is the total frictional force? So write total frictional force total frictional force, that is F1 plus F2. F1 plus F2, that means mu R1 plus mu R2. So you can write mu common, R1 plus of R2, and here R1 plus of R2, that is the total reaction force, is balanced with the weight of the car, that is mg. So you can write mu mg. This is the total frictional force F1 plus F2. Suppose this is our equation 1. Now listen, very important part. Here the frictional force which is directed inward towards the center of this circular track, and I previously told that the force which is directed inward provides the centripetal force for a circular path. So obviously here this frictional force, this amount of frictional force is provide the centripetal force. Now question is, what is the condition for which the car stay on this road? What is the condition? Obviously the condition, that is this frictional force, this amount of frictional force must be greater, or you can say equal to the centripetal force. This is the basic condition for which the car stay on this road. When this frictional force will be less than the centripetal force, that means this frictional force, this maximum possible frictional force is insufficient to provide the centripetal force. In that condition the car will skid. The car will skid off and outside of the road. So right, that is the condition for which the car stay on the road. So the condition for which the car stay on the road, that is mu mg greater or equal to, you can say equal to, that means the maximum condition, and greater, that is the easily the car taking a safely turn. So you see m cancel out. So from here you can write v square by r less than or equal to mu g. So v square less than or equal to mu rg. So you can write v less than or equal to root under mu rg. This is the condition. This is the velocity, expression of velocity for which the car safely take a turn. Okay. Now you see from this equation you can write v less than root under mu rg, one expression. Another expression you can write v, that is equal to root under mu rg. Now tell me, what is the maximum speed? What is the maximum speed for which the car take a safely turn on a circular track? This is the v which is less than mu rg. This is not the maximum speed. V is equal to mu rg. So this is the maximum speed, right? The maximum speed of a car for taking a safely turn along a circular path, or you can say along a circular road, circular level road. Okay. But if the velocity, that is v, is greater than this one, if the velocity v is greater than this value, then the car will take off on the road. That means in that condition the frictional force which is directed inwards, which is directed towards the center of the car, is insufficient to provide the centripetal force. So you can see here this velocity, this maximum velocity, or you can say velocity depends upon the r, that is the radius of the circular track, this one, Again you can say this velocities depends upon the coefficient of friction mu between the road and the tires. So this is the condition and this is the expression, that is the maximum speed. So I think this part is clear to all of you students. Today I am ending here. Bye bye.